In this video, I will be going over the Unit 4 exam review. Let's get into it. Our first question, so the graph represents the relationship between the number of hours Jane babysits and the amount of money she earns. Which of the following statements describe the graph represented above? Select all that apply. Okay, so let's go through each one of these and see whether they are correct or incorrect based off of this graph. Point A represents the money earned for each hour babysitting. Okay, well, if I look here, point A represents the money earned for for 2 hours babysitting, not for each, so I'm going to say no. B says that Jane earns $1 for every 8 hours. That is not correct because after 1 hour she earns $8. Jane earns $8 for every hour. That is correct. Point A represents the money she earned for babysitting for 2 hours. That is correct. A represents the amount of money she earned for 2 hours. And E says the total money earned for babysitting 5 hours is $40. Well, let's see. She babysits for $5 for 5 hours. And if I follow this all the way back here, it does end up being at 40. So on this one, there were 3 correct answers. Our next one says, which equation represents the money Kelly earned in relationship to the hours she works? Let M represent the money she earns and H represent the number of hours. So remember, all I need to do is find my unit rate. Once I find my unit rate, I want it to look like it is in the form y equals my number and times x. Okay? Unit rate needs to have a 1 in the denominator. Remember, I'm writing it in the form y over x. So here is my 1. If I follow this to my graph and go over, it is 10. So my unit rate is going to be 10 over 1, which means this is the correct equation. Notice how it is in the form y equals some number times x, except I have different variables for y and x, which is also okay. Our next one says, if Mark's package weighs 30 pounds, how much will it cost him to ship the package? Okay, well, it's going to weigh 30 pounds. So let's figure out how much it costs to ship 1 pound of package. Okay, so if I look here, this tells me that for every 20 pounds, I have to pay $10. So I'm paying $10 for 20 pounds. Let's figure out how much I'm paying for 1 pound. Okay, I'm going to divide by 20 on bottom and then divide by 20 on top. 10 divided by 20 is going to be 50 cents. So I'm paying 50 cents for every 1 pound. So if I'm paying 50 cents for every 1 pound, and Mark is going to ship this package that weighs 30 pounds, I need to multiply top and bottom by 30. And when I do 0.5 times 30, I get 15. So Mark is going to pay $15 for his package. I forgot to change the answer choices, so it's not one of these. However, this is how you would solve this problem. So first, find your unit rate, determine how much they charge for every 1 pound. Then take that price and multiply it by how many pounds Mark's package is. Okay. Our next question says that a scientist measures the size in square inches of a fungus for several weeks after he administers an experimental fertilizer. The proportional relationship is shown in the table. Which statement correctly describes the growth of the fungus in weeks 3 and 4? So what we need to do on this problem is, let's look at week 3 and 4. So it looks like on week 3, this plant is 6 3/4 inches tall. And it looks like at week 4, it grows up to 9 inches. So the first step is, let's figure out how much it grows from week 3 to 4. And to do that, I would take 9 and subtract it from 6 3/4. When I do this subtraction, I get 2 1/4. Okay, so there's a 2 1/4 growth, which means that these two options that say 9 square inches are both out because that is not correct. Then the next sentence is asking us whether it is proportional or not, because one says the size of the fungus is proportional to the week of measurement for any given week, and the other option says that it is not proportional. Well, I can tell you right now that I know this is proportional because this. if I look every single week, starting with week 1, this plant is going to grow 2 1/4 inches every single week. And if I wanted to double check, I could pull open a calculator, do 2 1/4 plus 2 1/4, I get 4 1/2. If I do 4 1/2 plus 2 1/4, I get 6 3/4. So since the amount that this plant is growing weekly is the same, that makes it proportional. So we want to make sure that I'm reading this carefully. So the fungus is going to grow 2 1/4 square inches, and the fungus is proportional. Our next question says that assuming the mule deer population is proportional, how many mule deer can the ecologist expect to inhabit the area of 25.5 square miles? And point B wants to know the 0.7, 2.5. What does this represent in this situation? Okay. Well, let's look at part A. So part A wants us to know. Part A is essentially asking us to solve for that question mark, which is going to be how many number of deer can live in that area. If I look at this side over here, I know that in 2.5 square miles there are 1, 2, 3, 4, 5, 6, 7 deer. Okay, so there are 7 deer for every 2.5 square miles. 2.5 square miles. So let's figure out how many deer can live in every 1 square mile. So let's divide top and bottom by 2.5. And since I'm dealing with fractions here, I am going to use a calculator. So I have 7 divided by 2. I'm going to do a space and 1/2. Oops, not 1/5, 1/2. So this tells me that 2.8 deer can live in every 1 square mile. Okay, so now that I know that, I'm going to take that 2.8 over 1, and I want to go to 25.5. So to get there, I need to multiply by 25.5, and I'm going to do the same thing up top. Okay, so I'm essentially going to take that 2.8, and I'm going to multiply it by 25.5. And I get 71.4. Now, this is interesting because I can't have 0.4 of a mule or of a deer, right? Because that doesn't make sense. So I'm going to round this down to just 71. So I'm going to say there can be approximately 71 mule deer in that 25.5 square mile radius. Part B wants us to just put words with what 7, 2.5 represents. And, well, I know 7 is the amount of deer. Okay, so there are 7 mule deer in every square mile. Well, that is not true because there's not 7 in every square mile. There's only 2.8. There are 2 mule deer habitats. One is 2.5 and one is 7. No. There are 2.5 mule deer. Nope. There are 7 mule deer living in the area of 2.5 square miles. This one is the one we want. So it has that 7 mule deer over the span of that 2.5 square miles. Perfect. Our next question says that an architect designs a division of townhouses. He uses the table to determine the number of parking spaces needed for the residents. The architect knows that this relationship is proportional, so he needs to offer blank 1 parking spaces per townhouse. This can be represented by the ordered pair blank. This one is actually pretty simple. Yes, it is a blank 1, blank 2 question, but it gives us the answer almost directly from the table. So if I know he needs to offer blank parking spaces per townhouse. Well, here it tells me that the number of townhouses is 1, and I need to offer 3 parking spaces. So for every 1 townhouse, I need to offer 3 parking spaces. So blank 1 is just going to be 3. Blank 2, which is our ordered pair, I could literally just do this. put parentheses and a comma in between them. So 1, comma 3. So this one is actually a very nice question. Our next one says that if the number of wins is proportional, how can you determine m, the unknown value in the diagram? So for this one, I think it's going to be easier almost to kind of solve for m first, because that'll take out a few of these answer choices. So I know that I get 3 wins after 1 track meet. Okay, and here I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 wins, and this is m. So if I take 3 times what number gives me 12? 3 times 4 gives me 12, right? So 1 times 4 is just 4. So after 4 track meets, I can get 12 wins, which means that this right here is wrong, this one here is wrong, and this one here is wrong. So it looks like the unknown value m is 4. So first, we want to calculate the unit rate, which is 3 wins per 1 track meet. And next, we can use this equation here, w equals 3t, and substitute 12. So the description is a little bit different from how we solved it. I think the way we solved it was a bit easier. However, since we were able to make sure that our unit rate, which is 3, is the same number used in our equation, it made it a little bit easier. All right, our next question says that a meteorologist recorded temperature changes in Modesto, California as a cold front approached. On Sunday, the average temperature decreased 4.4 degrees from the day before. On Monday, the average temperature had decreased 8.8 degrees. On Tuesday, the average temperature had decreased 13.2 degrees. And on Wednesday, the average temperature had decreased 17.6 degrees. Which point represents the temperature change as of Wednesday? Okay, so we need to kind of think about this a little bit abstractly from what is actually happening here. And think about our x here. So we have our x comma y. Think of x as the number of days and y as the temperature. Okay, so this experiment started on Sunday. So Sunday is day 1, Monday is day 2, Tuesday is day 3, and Wednesday is day 4. So it has been 4 days, and the temperature on Wednesday had decreased 17.6. So that means if it is a decrease, my 17.6 must be negative. So 4 comma negative 17.6. All right, next question. A full tank contains 8.9 feet cubed of helium, enough to fill 30 balloons. To calculate the amount of helium needed to fill 50 balloons, first determine the unit rate, which can be calculated as 30 over 8.90. Next, create an equation to represent the relationship between H, the volume, and B, the number of balloons. Okay, so and that is going to be blank 1. So blank 1 is our equation, and then it tells us to plug in 50 for B and solve, which would give us the amount of helium that is needed. Okay, so on this equation, it kind of gives us our answer for the first problem. Okay, because I know what my unit rate is. My unit rate is going to be this. It tells us right here it's this 30 over 8.9. So I'm going to pick the equation that uses that 30 over 8.9. So that is blank 1. For blank 2, it tells us to plug in 50 for B and solve. Okay. So I'm going to take 50 and plug it in for B. So I have 50 equals 30 over 8.9 H. On this problem here, I would suggest working backwards. So that means taking these 3 answer choices and multiplying them by this 30 over 8.9 to see which one gives us 50 as an answer. That is going to be the easiest way to solve this one. So bring our calculator over here, So again, working backwards, so I want to know which one of these numbers times 30 over 8.9 equals 50. So 30 over 8.9, let's multiply it by that first answer, which is 168.54. Well, that is way too much, right? So let's try the next one, 30 over 8.9, and I'm going to multiply that by 14.83. This one is very, very close to 50. If I look here, this 49.98, I could very easily round this up to 50. Let's double check that last one just to be 100% sure, and multiplying it by 18.73. Yep, this one is definitely over 50, which means that the amount of helium needed is going to be 14.83, because that is what we multiplied here to get this 49. Perfect. All right, next question. A computer was regularly priced at $1,600. If you order the computer online, you can save money and the price is only $1,280. What percent discount are you getting? Okay, so here is going to be our part over whole equals percent over 100. Where's my little, there it is. So part over whole equals percent over 100. The whole price of my computer is $1,600. The part that I'm paying is $1,280. I don't know what my percentage is. I'm going to put this over 100. So next is going to be our multiplication, cross multiplying. So 1,280 times 100. Put my equal sign. Then I'm going to multiply the other way. So 1,600 times x. Let's multiply this out. Again, feel free to type this into a calculator to make sure that you are not missing any zeros. And then once we multiply it out, I'm going to divide by the number next to my variable. So 1,600 I'm going to be dividing by on both sides. And I can type that into a calculator. So 128,000 divided by 1,600. Which tells us that I am paying 80% of the price of the original. So I'm paying 80% of the original price, okay, which means that it is 20% off, because that 20% is what is missing, so that's the discount I am getting here, okay. So this one's a little bit backwards. You have to think about it. Well, if I'm only paying 80% of the full price, that means that it is 20% off, because that is the amount of percentage that I'm not paying. Our next one says that a fruit punch bottle says it contains 20% fruit juice and it is a 300 milliliter bottle. How many milliliters of fruit juice are in the bottle? For this one, there's a simpler way to solve this, and it is to take our number, which is 300, and multiply it by our percent, which is 20. Okay, so if I take 300 and multiply it by 20%, you have to remember here that you need to change your percent to a decimal first. Okay, and remember to do that, I take my percent and divide it by 100. So when I do that, I'll get 0.2. So 300 times 0.2, again, feel free to type this into a calculator. When I type it in, I get 60. So that means that the total milliliters of fruit juice in this bottle are 60 milliliters. Our next question says, if 25% of y is 30, what is 60% of y? This question is tricky just because we haven't done one like this before, and it's kind of two steps. The first part of our question is this right here. So if 25% of y is 30, so once I figure out what y is, then I need to figure out, well, what is 60% of y? Okay, so let's do this first part here. If 25% of y is 30, so I'm taking 25% of this y, so I'm going to multiply it by y. That is going to give me a final answer of 30. So 25% of some number gives me 30. Okay. Remember, before I start working with this, I need to change this percent to a decimal. So again, divide it by 100, you get 0.25. Y equals 30. This looks very similar to our last step when we're cross multiplying, which is to divide both sides by the number attached to my variable. So I'm going to do that. So when I do that, I'm figure out that y is equal to 30 divided by 0.25, which is 120. Okay. So this is telling me that y is 120. So y is that special number. So this says if 25% of 120 is 30, what is 60% of y? So the next step for this problem is going to be doing this part here. What is 60% of y? And I know y is 120. So I'm going to take this 120 and multiply it by 0.6. What I did was did 120, multiplied it by 60%, but I changed this percent to my decimal, which you have to do before you multiply it. Then I'm going to bring back my calculator and I'm going to do 120 times 0.6, which gives me 72. So my final answer for this question here is going to be 72. Our next question says the original price of a bicycle is $180. Jeremy bought the bike at the time when the store was having a 20% off clearance sale. What is the price of the bike that when Jeremy bought it? Okay, so for this one here, I could take that 180. If I take 180 and multiply it by 20%, this is going to give me the amount of money discounted. Okay, so this is how much money I'd be saving off the original price. But before I can multiply these, remember I need to change this 20% to a decimal, which is 0.2. Again, you can take 20, divide it by 100 in a calculator, and you will get your decimal. Once I figure that out, I just need to multiply them. So 180 times 0.2, which is going to give me 36, okay? So $36, this is how much money was taken off of the bike. This is not how much I pay for the bike. Okay, think about it. 20% off is not that big of a discount, and if the bike is normally $180, me paying $36 does not make sense, because that is way more than 20%. So my final step is going to be taking my original price and subtracting it from how much money I am saving. And when I subtract it, I get 144. So Jeremy paid $144 for his bike. Alright, our next one. This one's slightly different, but we're going to use the same type of strategies we have been using to solve it. A candy bar cost the store 85 cents. Find the price of the candy bar if it is sold with the 65% markup. Okay, so here the store has to buy the candy bars for 85 cents, but they need to make a profit when they sell it. So they're going to increase the price of that candy bar by 65%. So again, I'm going to take my price of my candy bar, which is 85 cents, multiply it by 65. Whoops. 65%. Okay. And this is going to give me the amount of money it is increased by. Okay. And again, don't forget I need to change my percent into a decimal first. And then I'm going to take that number and add it to my original price. So that's going to give us some number answer. And then since it is a markup, the price is increasing, so I'm going to take that number and add it to the price that they pay for the candy bar. Whoops, this should be a 5, not a 6. I'm glad I caught that, otherwise my answer could be slightly off. Alright, so 0.85 times 0.65. 0.85 plus 0.55. And that tells me that they're going to sell this candy bar for approximately $1.40. Alright, very last question. In an experiment, the temperature of a sample is measured as 18 degrees Celsius. If the percent error is 0.75, how can you report the temperature using a sample of the absolute error and the actual temperature in degrees Celsius? So the only number that we're really solving for here is that second one, because if you look at all of our answer choices, they all start with 18, which is the number that we have up here. Okay, and to figure out the second number, all we need to do is take our 18 and multiply it by this 0.75%. Okay, but this is where you need to be extra careful, because normally when we're multiplying by percents, we change it to a decimal, and our decimals can sometimes look like this. But this is still a percent. I have not changed it to a decimal yet. So 0.75 as a decimal is 0.0075. Okay, so make sure that you're not forgetting to change it into a decimal. On this one, it's the easiest way to forget it because our percent already looks like that decimal. And I just realized that my answers are slightly off because I forgot to change them, but that's okay. So I have 18 times 0.0075, and I get this 1.35. Okay, so that means that the answer choice that I would want to pick here would be 18 plus or minus 0.14 probably. However, I forgot to change the possible solutions. But this is how you would solve the one on your exam. You're just changing the numbers to match the numbers that are on your exam. But it's the same thought process. Okay, this is the last question for the exam review. If you would like another attempt on your exam, please let me know. I would be happy to do that for you.